So if you remember this slide last week, okay, this particular device is an example of a DFA. Okay, थोड़ा ऊपर लेता हूँ तो इसको आपको ज़्यादा समझ में आएगा. So this is an example of a DFA. This is an example of an NFA. Okay, and this is an example of also for an NFA. Okay, ये दोनों NFA के एग्जाम्पल है. इस एग्जाम्पल में आप देखोगे कि इसमें इस पर्टिकुलर डिवाइस में if I am in Q0 and I see an input 1, I have a label 1 here for this transition, and I also have a label 1 here for this transition. Means I have option for being in Q0 or moving in Q1. Okay, so there are two options I have, right? And over here, when I'm in Q0 and I see an input 0, there is no transition defined. As there is no transition defined, I will have next state as epsilon. So both of these devices are NFAs, one on account of having at least one transition extra for input 1 when being in Q0. And this being an NFA on account of not having or missing one transition when you are in Q0 and input is 0. Okay, so this is the differentiation between an NFA and DFA. Now they say that DFA is a constrained device because we require an FA to become a DFA. We require that the transition function is one-to-one correspondence between current state and current input and next state, and it is an on-to kind of mapping. तो यानी हर एक सेल में there is exactly one next state must be defined for a device to be a deterministic finite automata. For NFA, it's a relaxed version of DFA because I may not define certain transitions, or I may define multiple transitions on same input symbols. I'm allowed to do that, and that is why we say that NFA is a more relaxed device. Okay, I hope these two ideas are clearer to you, and you now know what do you mean by determinism. When a device FA without output is called as deterministic device, and how to identify given an automata whether it is DFA or whether it is NFA. Okay, can you just tell by raising your hands that you have understood what do you mean by a deterministic device? Can you just raise your hands if you understood what do you mean by a deterministic device? Yes, I'm able to. You are able to hear my voice, now, all of you. So please quickly
Yes,
tell
sir.
me. Yeah, quickly tell me if you have understood this or you want me to explain it again. So do you want me to explain it again when to call a device deterministic? Please raise your hands. तो दोनों तरफ से नहीं बोलते. Is there any delay in my communication? Okay, so I'll assume since you are not raising your hands for whether I need to explain it again or you have understood, दोनों के लिए हाथ ऊपर नहीं कर रहे हो, तो मैं assume करता हूँ कि you have understood it. And I'm moving ahead. I'll now give you an example device, and now we'll try to identify whether it is a deterministic device or whether it is a non-deterministic device. Okay, and what all things that device has. So I'm just going to give you certain examples. Okay. The question, don't read this question for now. Okay. Just the question that I'm asking you based on. So these are three devices, by the way. This is device 1, this is device 2, and this is device 3. Okay. So I'm going to go one by one on these devices. So is this device 1 a deterministic finite automata? Okay, I want your answer to be either yes or no. whether this device is an example of a deterministic finite automata. So how you will identify whether this is a deterministic finite automata? कुछ बाकी पता नहीं होगा, तो अगर कोई ऐसे डिवाइस आपको ट्रांजिशन डायग्राम दे के दिखाया जाए, simple thing you can do is you can create a table called as transition table. Okay, so I already said what is a transition table. You enlist queues in rows. So there are two rows because there are two queues. First queue is Q0. Second is Q1. Okay, out of Q0 and Q1, Q1 is my initial state. How do I identify that? Because of this arrow. Also, Q0 is my final state. How do I identify that it is a final state? It is drawn in double circle. Okay, then I have alphabets 0 and 1, right? So there are two alphabets. So on the column side of this table, I always have alphabets. In this case, I have two alphabets. I'll be writing 0 and 1. Okay, please understand we are trying to answer the question whether the given device is deterministic or non-deterministic. You will have these abilities once you practice a lot, but अभी जब आपके पास abilities नहीं है, by looking at diagram saying whether the device is deterministic or not, you take help of this transition table. So now try to fill this transition table. Identify what state you are in when you start the device simulation Q0. What you do when you see an input 0? When I see an input 0, I follow this transition. So I still remain in Q0. I just put that value inside the table. Okay, so I am in Q0 after I see an input 0. When I see an input 1 and I'm in Q0, I follow this transition, okay, this one, to reach to Q1. Okay. When you are in Q1 and you see an input 0, it's a self loop. Okay, it is easy to fill up this table, right? You will understand now how to fill up it. Q1 to 1, I go back to Q0. Right? Very much straightforward and easy. I hope it is for you. Okay, did you understand how did I fill the table? Now I count the number of transitions. 1, 2, 3, 4 transitions are there. 4 cells were there, and now these 4 transitions are filling all my 4 cells with exactly one next state. So what this makes, so this particular property in mathematical terms or in mapping terms is called as total function. In mathematical term, this property is referred to as total function. Total function क्यों? क्योंकि हर एक सेल में exactly one next state है, इतना याद रखो. So this makes this particular device a FA, that is DFA, deterministic finite automata. I hope this discussion is clear to you all, and you now know, given a transition diagram, you will be able to identify whether the given automata is deterministic or not. पहले वो automata ये कैसे पता चलेगा? You should have Q, Q0 Q1 है यानी Q है. You should have sigma, 0 1 है यानी sigma है. You should have an initial state Q0. You should have a final, at least one final state, that is Q0, right? So all the ingredients are there, and this is my delta. This is the transition function delta, okay, which is a mapping between current state, which is marked by set Q, current input marked by set sigma, mapped to the next state. Again, it is mapped by Q. Okay, so this particular mapping makes my device a FA. Okay, this kind of mapping makes my device an FA. Now, please understand a particular thing, that if my device is not a DFA, this particular mapping in mathematical terms, you write it as Q cross sigma mapped to 2 raised to Q. Okay, so this is the mapping, or this is the delta for this particular delta is a delta for NFA. I'll come back to this discussion once we finish discussing whether the last two examples on this slide they are DFA or NFA. और ये नीचे वाला जो है, this is for DFA. Okay, just need to change the color. जो नीचे वाला है ये जो है एग्जाम्पल, ये है NFA DFA का एग्जाम्पल डेल्टा का. This is an example of delta for DFA, and above is the example for NFA, delta for NFA. Now this is a new notation, 2 raised to, this is not A by the way, actually मेरा writing की वजह से वो शायद A दिखता होगा, it is Q. Okay, it is Q, 2 raised to Q. Now what is this 2 raised to Q? ये कहाँ से आया? ये set theory से आया. So this set which is referred to as 2 raised to Q, okay, is nothing but, in set theory this is referred to as a power set. What is a power set? That is what we need to understand first. So power set क्या होता है? अगर मैं आपको एक सेट Q दूं जिसमें एलिमेंट्स है 0 1 2, अरे सॉरी क्या हो गया, 0 1 2, okay, then set 2 raised to Q is defined as set of, okay, I require phi. Did I copy phi that day? I don't remember. Might have phi somewhere. Sigma hai. Give me a second. I'm just searching for phi symbol. Because drawing those symbols, मैं कुछ अजीब ड्रॉ कर देता हूँ, बाद में जाके मुझे पछतावा होगा जब आपके एग्जाम में मैं देखूंगा. So let me just search for phi somewhere. Phi is not there, so let it be. I'll just bring phi from Word document into the slides set. Okay. See, I want a phi and I want a phi here. Okay, not here, here. Okay. Let me bring certain symbols from my Word. Insert symbol. Yeah. So I'm not good at ASCII encoding. तो अगर मेरे को यूनिकोड encoding ठीक से आता होगा तो I guess we can directly use this /u 3d5 to print this particular character. लेकिन मुझे वो नहीं आता. Sorry for that. Just bring phi from here. So the first element of this set is phi. Okay, and phi क्या होता है मैंने पहले बता दिया था आपको. Phi होता है empty set. Second element in this set is set 0. Third element of this set is set 1. Fourth element of this set is set 2. Fifth element of this set is set 0 1. Sixth element of this set is set 0 2. Seventh element of this set is set 1 2. And the final element in this set is set 0 1 2. Okay. So if you see the size of 2 raised to Q, it will be 2 raised to size of Q. Okay, size of Q कितना है 3. So 2 raised to 3 is 8. Okay? And that is why the notation power set का notation जो है वो उस हिसाब से आया हुआ है. Now my original set is Q. Size of Q is 3. Okay, ये जो notation है that represents size of a set. Okay, size of a set is number of elements in the set. So there are 3 elements in the set. I have this set to be, size of set to be 3. Okay, this is the 2 raised to Q set, which is set of all subsets. So what is a power set? So definition of power set is power set of any given set is set of all the subsets of that set. Its cardinality is related to original set with a power relation. Okay, power relation मतलब ओरिजिनल सेट का जो साइज रहेगा या कार्डिनलिटी मीन साइज ऑफ द सेट. Number of elements in a set in set theory is referred to as cardinality of the set. Okay, so with this example we know what is a power set. Power set is generally denoted as 2 raised to q. Q is 0 and 2. Mod of q is 3. Okay, 2 raised to q may have all these sets as an element. Now why we are using a notion of power set in the definition of NFA, that we'll understand. NFA में हम लोग क्या बोलते हैं? Q cross sigma. Okay, again I require a symbol. ये भी लगेगा. So I just have both the symbols copied down. ठीक है, जितना लग रहा है उतना लेता हूँ. I've kept it open, so no problem. So Q sigma map to, so the delta function we require it to write in, I'll be using arrow. Can map an arrow like this, so no problem. It's a mapping between Q cross sigma map to is mapped to 2 raised to Q. Okay, the reason behind this mapping I use as delta, I'll tell you that. Let me just insert one more symbol which is delta. मैं symbol deliberately आज use कर रहा हूँ because these are mathematical subjects and you should use the symbols wherever they are appropriately. Okay, if you do not use those symbols and you tend to forget those symbols, that will be a mistake, क्योंकि बाकी के लोग अंडरस्टैंड नहीं करेंगे कि आपको क्या कहना है. अगेन मैथमेटिक्स सिंबल्स आर वेरी इंपॉर्टेंट. ओके, तो ये प्रॉब्लम हो गया कि ये वाला जो एरो है, टच दिस पार्ट. नो, I cannot touch this part. Can I clear this part? Okay, I can clear this part. So now this is the map. Q cross sigma is mapped to 2 raised to Q. So ये मैपिंग हम लोग क्यों यूज करते हैं? तो 2 raised to Q में क्या है? 2 raised to Q में 5 होता है. 2 raised to Q में set 0, set 1, set 2, set 0 1, set 0 2, set 1 2, set 0 1 2. ये सब combinations होते हैं. What these combinations are representing? So if I am mapping current state, current input to no next state. No next state कैसे पता क्या कब होगा? When I select phi from this set. Okay, whenever I select exactly one next state, 1 2 or 3, इन तीनों में से कुछ एक में select करूंगा. When I want to select multiple next states, I can select either this subset, this subset, this subset or this subset. So ये जो power set मैं बना रहा हूँ, which is the set of subsets of original set, it is helping me define these two situations. ये वाला situation और ये वाला situation. ये वाला situation कब? When I select that phi set. That means there is no next state defined. Okay, on current input, current input and current state and current input, I don't have next state, then it is not written as epsilon, it is written as phi, because I choose the next state to be phi from the 2 raised to Q subset. I hope this is clear to you. Whenever in this case I am selecting 0 1, तो यानी मैं 0 1 subset को select कर रहा हूँ. I can be in subset 0 1 of the power set. तो अल्टीमेटली हम लोग मैपिंग कर रहे हैं एक सेट का दूसरे सेट के अगेंस्ट. सो व्हाट आई एम ट्राइंग टू मैप नाउ इन दिस केस is Suppose I have these three sets in Q and two inputs 0, 1 in alphabet, or AB in alphabet, I should say. Then what I'll have is this particular mapping is actually एक टेबल बनाता हूं तो आपको ये ज्यादा अच्छी तरह से समझ में आएगा. So my current state either can be 0, current state either can be 1, or current state either can be 2. And suppose there are two inputs A and B. So this 0 can be combined with input A to produce a pair 0A. Okay. Then I can combine 0 with B. Then I can combine 1 with A. Then I can combine 1 with B. This is how I can produce this cross product. 2 with A and then 2 with B. I hope you understand what I'm trying to represent. I'm trying to represent the cross product, which is part of left hand side in this particular mapping. ये वाला left hand side जो है is this cross product. Okay. On the right hand side I have 2 raised to q, which is 5, 0, 1, 2, 0, 1, 0, 2, 1, 2, and 0, 1, 2. How many are there? They are 8, and these are how many? 6. Okay, so I'll be writing those as well on this side. Get the space for writing it. So I may have 0. On the other side, on the right hand side, I have these sets. I may have 1. I may have 2. I may have 0, 1. Okay. I may have 0, 2. Then I may have what? 1, 2. ये 6 हो गए, 7 है, total 8 है, right? So I'm just writing it besides. Don't worry about it. Okay, and finally I have something called as the phi. This. Okay, these are the 8 things to which I can have a mapping. Now suppose on input 0A, I am mapping it with this, indicates that there will be a transition from 0 on input A back to 0, and one more transition from 0 on input A mapping to state 1. Okay, when I say that 0B is mapped to phi, that means on input B there is no transition defined in state 0. So 1A, I may actually have a transition to 0, and 1B, I say suppose I have a transition to 0, 1. Okay, 2A, I may have a transition state 2A, I have a transition, so I should actually not define like this. So I'm just writing an example mapping I'm writing. Okay, we'll reconstruct the table and transition diagram from it, and then probably we'll understand what this particular device is like. 2A probably is mapped here, and 2B is mapped here. Okay, so this is some mapping that I am defining. Okay, this mapping, if I want to realize it as a transition diagram, I can realize it like this. This is my state 0, this is my state 1, and this is my state 2. Okay, while I'm specifying the mapping, I'm not specifying which is the initial state, which is the final state, and other things. Okay, that I'm leaving right now. I'm just talking about the transition function. Okay, we start the. So suppose Q0 is my, or state 0 is my initial state. I'm assuming that the state 0 is my initial state. Based on the information that we have, sorry, I cannot, okay, I'll move this up here. So this is state 0. This will be my state 1. Okay. It takes time for writing all these things. be patient, but you will understand ultimately what is going around. So don't worry about it. So uh, on 0 on A input, I'm moving to 0 1 set. 0 1 set matlab there are two states I can move into. On input A, from 0 state, I can move to state 1, or I can be in state 0. That is, there is a self loop. Okay, तो ये चीज इस तरीके से दिखाया जाएगा. So here is the label A. Okay, similarly there will be a label A where it will be here. Fine. So that is 0A. I'm moving on to 0 1 state. 0B, I'm moving to 5. That means on B there is no input from state A. 1A, I'm moving into 0. So 1A, there is a back transition that takes me over here. Now this is a okay, sorry. 1B, I'm moving on to state 2. Okay, was my connection disconnected for a moment? You're able to hear me clearly?
Yes, sir.
ओके, कनेक्शन मध्ये डिस्कनेक्ट झालं होतं का? मला आता
येस सर. हाँ
किती
सर.
वेळ, कितनी देर के लिए?
सर अभी भी ब्रेक हो रहा है वॉइस.
ओके, अभी भी ब्रेक हो रहा है वॉइस. एक्चुअली मे बी दैट इज ड्यू टू द internet connectivity. Let it be. I'll just complete this and then maybe I'll just recap what I did. It takes some time for drawing all these things. बोर्ड पे झटके झट से ड्रॉ हो सकता है, but here in this scenario I require certain time. So 2A goes to 1, 2A goes to 1, और मैंने नीटली ड्रॉ नहीं किया तो बाद में जाके मुझे ही पछतावा होगा कि आपको समझ में नहीं आएगा. I have to redo all the things. Let it be. So 2 on input A, I'm going back to 1. And 2 on input B, I'm going back to 2. That is, there is a self loop again. Okay, I don't know which are the final states and other things. Only the thing that I am right now concerned about is what is the makeup of my transition function. That is what I am interested in knowing. Okay, that is what I am interested in knowing. To B is like this. Okay, so this is the makeup of my transition model. I know my initial state because I considered or assumed that maybe my final state is state 2 or state 1. I may consider my state 1 as my final state. Okay, it's up to the computation that I'm doing. Depending on that, I will define my final state. So consider that 1 is my final state. I had not told you that earlier.